I hope you're having a good 2026. We're going to start doing more of these kind of live trainings where we actually, instead of just like PowerPoints and stuff like that, we have the actual components and we can go through them. And today's is going to be a Suburban water heater, a tank Suburban water heater. Now, this one that I do have happens to be a 10 gallon rather than 6 gallon, so it may be a little easier getting into pulling apart everything than your average 6 gallon, which is the more common size that you'll get. But overall, it's the same item. Okay. Just kind of spread out a little bit larger. That's all. Now, to diagnose this water heater, let's talk about the tools that we have here. All right. And really, it only takes these two. You can certainly use a combination of different tools to do this, whether it's a test light or anything like that, but a standard meter. Now, I do have a amp clamp meter. All right. This one happens to be for 400 amps. And then I just have a multi screwdriver. Now you can use all different types. This one just happens to have the 1/4 inch size I need for the screw nuts, and just a Phillips also that you'll need for this. Now, before we actually get into the water heater that's right here, I'll kind of pan by it. All right. We're going to talk about the components. And then as we're talking about the components, when we come back to this, I'm going to emphasize them and what they are. So first, we'll start off with the replaceable components. Okay. I have them all written down here so we can kind of get an idea of what we're looking at as we actually get under the water heater. But first thing I'll start with is control board. Control board, in my opinion, it doesn't matter really what appliance is, the most common replaced component in any appliance. All right. Now, Suburban, by far less replacement compared to other water heaters, but still a very common replacement component. Next is going to be a redundant gas valve, and I'll talk about the redundant gas valve as we get there. But another common part to fail internally and then externally, and we'll talk about what the difference between internal and external failure is on those as we go by. Sparker and sense probe assembly. This is a funny one. The sparker and sense probe gets replaced more often than I feel that it should. Most of the time, a cleaning does these sparkers just fine. When you start to need replacement on these, it's oftentimes because they're damaged in some capacity, whether it's the ceramic on them and they're prematurely sparking or something of that nature. Most of the time, they do just need a cleaning, though. The element, and when I talk about the element, we're actually going to go over diagnosing an element a couple different ways. But what we're talking about there is the 120 element. The element relay, this one, depending on the model, and I'll speak more on this, is going to be dependent on whether it has a element relay. All right. Now, this is a little bit newer. All right. But you'll get ones that are 5, 6, 10 years old, even older, that may not have an element relay in them, and they just have a switch. Okay. And I'll highlight what the difference is and where the switch might be. And then we have our gas operation limit switch and thermostat combo. All right. And when I say limit switch, you may also hear me refer to it as an ECO. And what an ECO is an energy cutoff or emergency cutoff. It doesn't really matter kind of what you call it. Just understand it's designed to protect the water heater from overheating. So that's what the limit switch does. Now, Suburban calls theirs an actual limit switch. Other companies call theirs an ECO, but they're the same thing. All right, really. And then we have an electric operation one that does the same thing, limit switch, thermostat combo. So Suburban has their own limit switch and thermostat combo for the gas operation, and then a totally separate one for the electric operation. And I'll show you all that as we go on. And then the P&T valve, obviously a replaceable component. We'll talk about a couple things with the P&T valve. There's a lot of different feelings on acceptable practices and what is okay and what is not when it comes to a P&T valve. I have my own feelings about it. Some other technicians on the phone might have some other feelings about it. And that's okay. All right. I don't know if there's really the most correct answer when it comes to people that actually touch the P&T valve, but we'll talk about what it does, how it works, and if it needs replacement, a couple tips. Okay. Now over on this board, we'll get to this board. This is some different diagnosing things that we'll talk about, but we'll start with the control board on it. So I just want to kind of show you the control board on this one. Now, this is just a standard printed circuit board, okay, with a sparker kind of piece on it. Now, this printed circuit board is a little bit different than ones you'll see on like your Atwood / Dometic ones. That is considered a potted circuit board. And the reason that it's considered a potted circuit board, because it's in an actual plastic enclosure and then sealed with a non-conductive, um, like non-conductive material, almost like a non-conductive silicone. That way it can be on the exterior and not become damaged from the elements and everything like that. Now on a Suburban, they do tuck this on the back. Sometimes it's like taped here. It does have a cover also, but it's like a lot of the time on top of the water here in the back of it. All right. Or on the side of it, they'll zip tie it to the little strap here sometimes, but it's going to be located on the interior of the water heater itself. Now you'll have some wires coming off of that, and we'll talk about what those wires are. But a lot of times, like I said, that is the culprit. These things fry out. They're just like printed circuit boards. So, all right. But other than that, the only other things you're going to have on the interior, the 4 wires, all right, that are going to be attached, and we'll talk about what all those 4 wires do, and then also the 120 electric connections will be on the interior of the unit. And in this one just has a outlet. It's like a 120 outlet that would plug into a outlet on the interior of a unit. And then here it has your relay, and that's going to be that relay, that element relay that we were just talking about. And that is a 12-volt activated relay. And we'll talk about that some more when we start diagnosing this. But we'll start with diagnosing this with the wires that are attached to the water heater itself. And it's going to be these 4 wires right here. Okay. So on this Suburban, okay, pretty much all Suburbans, they're going to be the same color. And just like Dometic or Atwood, they're going to be the same color on that too. So we have a red, a blue, a green, and an orange wire. We will start with the green one because I always think that the green one's the easiest one to always think about. And that green one is going to be ground. It's going to be ground attached to the unit. So that should always be a ground when it comes to the unit. Next one we're going to have is the blue. This blue one oftentimes gets overlooked. All right. This is the DSI fault light wire. So if this water heater starts to fire and fails to light within 3 tries, 12-volt power is sent from the control board through this wire to illuminate the little DSI fault light that will be on the panel of the unit next to the switches and stuff like that. All right. The next wire that I'm going to talk about is going to be an orange wire. Kind of see it there just a little bit. But if I go back over here, okay, you'll see it. And this orange wire, what this orange wire does is when you have 12 volt come from a switch on the interior of the unit, that little orange wire, when it has 12 volt to it, activates that relay that allows the 120 volt AC operation to start functioning. So basically, just sends 12 volt to the orange wire, activates this relay, and allows the 120 to flow through it, and then through the different components, which we'll talk about here in a second. And then the last wire, all right, it's probably the most crucial, the most important one that we have the most problems with, I would say, when it goes through this, the kind of the circuitry of this, is the red wire. And the red wire actually is just a 12-volt activated wire also. All right. And what we do is we take 12 volt from a switch on the interior of the unit and we send it to the red wire, and it takes the path. And we'll talk about what the path is right now. So when we send 12 volt through that red wire, comes over here, down behind this little board. Okay. This little plastic cover right here. This plastic cover houses both the 120 and the 12 volt gas operation, limit switch, and thermostat combo. So I do have the screws off real quick. So I'm going to take this off and you can kind of see. All right. And you'll see there's a couple of red wires on the right side and then some black wires on the left side. The right side is going to be the gas operation right here. The left side is going to be the 120. Now you see me poking and prodding in here right now. If you had this thing hooked up to 120, I wouldn't be poking and prodding here with my fingers or anything like that on a regular basis, because you will get shocked if you're not sure exactly what operations it's on or what switching is going on or anything like that. So always be careful. But because I know I'm not hooked up, I can poke and prod in here. But right side is gas operation, left side electric operation. Okay. On the top, all right, these two right here. Okay, these are the limit switch or ECOs that I was talking about. All right, these are both manually resettable. So if this thing overheats at all, these things will pop, all right, and they'll allow you to manually reset them. On the bottom of them is the thermostats. All right, so normal operation when this reaches temperature. Hold on. All right, sorry, I had something pop up on my screen. When this reaches temperature, it will basically shut off the operation. This will become what's called an open, all right, not allowing current to flow through the wire and cut off the operation. Same over here too on the electric side. All right, when it reaches temperature, whatever it's set at, this one could be somewhere between 120 and 140 degrees Fahrenheit. This becomes from the closed switch in normal operation to become an open and not allow any current to flow through it and shut off the operation. But that is going to be your limit switch and thermostat combos. Now, let's talk about how to actually diagnose these. Okay, very simple. Pretty much, I gotta say, most components on our standard appliances are very easily diagnosed. Okay, and the tool you use to diagnose is right here. All right, just a meter. All right. Now, always make sure that when you are diagnosing, okay, using this type of diagnosing, you're always making sure that this is de-energized. All right, so you want to make sure no power is running to it, but all you're going to do is you put it onto the ohm. Okay, ohm continuity one right there. You can kind of see it's the omega symbol. All right, and right now it should say OL because I don't have any connection. Now, OL is construed in many different ways. Open line, over limit, open circuit. It doesn't much matter to me what you consider. Just understand that it's an open. All right, no current can flow to it. So what we'll do is we'll take it. Now it's gonna be a little harder for me because I'm shooting with one hand and diagnosing with the other. But you'll take one. I'll just kind of set it here so you understand. You take one. Can everybody see that? Set it there. Okay, and I'll take the other one. All right. And basically, all I'm doing is I'm going to go on one side of that ECO, one side of the thermostat to the other side of the thermostat, and I'm looking for a number. Okay. Now you can hear the beep too. A lot of meters have a tone, but I'm looking for a number. A number indicates to me that there is continuity. There's resistance in that. And when there is resistance, that means there's connection. Okay. If there was no connection, the meter would continue to read OL. Okay. So if that has connection, that indicates to me that is a good component. All right. And I can do it to all four of these. All right. To the limit switch up here. All right. Just touch both sides with your meter. All right. To the thermostat on the gas side, to the thermostat on the electric side, and then to the limit switch on the electric side. That's how you test all those. All right. And you can also test it to where, and this used to happen to me quite a bit. You see that there's a crossbar here, right? There's one on both sides. There's a little crossbar between your limit switch and your thermostat. On the electric side, if customers take, say, maybe they're camping and they take a lightning strike, maybe there's a lightning storm, it's a very common thing to have this little crossbar actually burnt out. All right, so you may not have any connection between the limit switch and the thermostat, so you would have no operation on electric. It wouldn't work. It wouldn't allow any current to flow through that little crossbar. Therefore, no operation would ensue. All right, and that's how you diagnose those couple components. Any questions so far? Okay, so we talked about that red wire. That red wire goes up to your limit switch thermostat, goes to and through everything because it's a closed circuit. Then it goes back to the control board. Okay, so I'm going to pick up the control board. You'll see a red wire here. All right, that red wire goes back to the control board. All right, once it makes it to and through that limit switch and thermostat, and it goes to the control board says, okay, I made it through my safety circuit. Okay, now I can continue operation. What is that continued operation? Well, we need to open the gas valve to allow propane to flow into the burning chamber, and we also need to start sparking. And it almost happens simultaneously, is what it seems like. But in reality, what happens is we start sparking just a little bit before we open the gas valve. And the reason that is because we want to fire any residual gases that might have been left in that burning chamber from the previous operation before we add new fuel to that chamber. What would happen, if anybody wants to answer, what would happen if we added more fuel to existing fuel and tried to ignite it after? Anybody know what would happen? Rather than trying to purge what we had in there before? Anybody want to take a stab at it?
It's either not going to do, or it's going to go boom.
Yeah, you're going to have
Fireball.
a boom, right? Yeah, you could have a little shoot back on there, right? We don't want that. It's actually something common too right now that happens a little bit with our current gen Dometic water heaters. Oh, okay. My meter always yells at me when I leave it on. With current gen Dometic water heaters, where we have a little blowback on those, and it's the reason that a lot of you recently might have been replacing that little thermal fuse that's on there, that little plastic clear thermal fuse that's in there. You have a little bit of blowback, and that's what that's designed to ultimately do. Is that is if you have fire jumping out of that chamber, it blows that thermal fuse so that it stops the operation. But that's what we don't want to have. We don't want to have any blowback with that. So we start ignition, all right, and spark it up before we add any more fuel. But all right, so that's your sparker wire right there. All right, and also recommendation to all technicians: when you're trying to diagnose this and you turn this thing on, don't touch this wire while it's doing sparking. I don't care if it's well insulated or not. Those things can hurt sometimes if you're not careful. All right. So that's your sparker wire. Now, the other thing that happens, all right, we just talked about needing to open the gas valve, is we send 12-volt power out of this brown wire right here. And this brown wire goes all the way behind this cover, all right, and then all the way up through this little hole here to our gas valve. All right. Now, this is our redundant gas valve. All right. Now, I've already taken the screws out of this one, so we're going to take it apart and we're going to take a look at the gas valve real quick. All right. So the gas valve here, all right, has two wires, well, technically four wires attached to it. It has brown that's jumped over. Okay. That's 12 volt to the two coils there. And then there's two black wires. And the two black wires just ended up going to ground. All right. Because we always need to finish the circuit. So we need to have our ground. So what we're going to do is we're going to disconnect two brown wires and we're going to take it over to the bench over here. And we're going to do a little diagnosing on this, because diagnosing a gas valve can be a little funny sometimes. And the reason I say that is because we don't think of the gas valve all the time when we are diagnosing. It's more of a last thought. All right. But these do fail. So I want to talk about it. So a couple ways to diagnose a gas valve. All right. And first thing I always like to do is listen. Okay. And what I mean by listen is this will make an audible thunking sound when it's activated. It'll go click and thunk open. All right. When it thunks open, it allows propane to flow. Now, when it opens, what it's doing in essence is it's sending current through these two items. All right. This is your coil. Right. And there's two coils. That's why they call it redundant. When it sends a current through those coils, it creates an electromagnetic field and pulls two plungers that are in this gas valve up into this chamber in essence. Okay. When it pulls them into this chamber, it allows the propane to flow. Now, diagnosing this is really ultimately easy. Okay. You can check for power to it. All right. Either using a meter, all right, or something like a test light, or you can actually pull it off like I did, and you're going to place your meter again on continuity. All right. And you're going to check across the coil. All right. So I'm going to pull the two connections here off. Hold on. I needed to be born with one extra hand. It would make this much easier, right? All right. And what I'm going to do is I'm going to take one lead and my second lead and put it there. And what I'm doing is I'm looking for a number. All right. If it says OL, that tells me that coil is bad and this thing is not going to allow current to flow through it to pull that plunger into place. Now, all your coils on all your redundant gas valves, all right, are going to be right around a 40 ohm coil. So I'll show you that again so you can see it on the meter. It's going to be a 40 ohm coil. Okay, so there's 40 ohms there. This one's 40.3. All right, and the other one, if I go to the other one, all right, you'll see that one's 40.2. So if that resistance is off by a bunch, it may also cause you to have a bad coil, which will not allow your gas valve to open. All right. So really, most of the time, if you just check continuity, it will tell you if you have a bad coil, because most of the time when these coils go bad, they just go open. All right. It won't allow any current to flow. All right. But sometimes they could go bad in an ohm reading. So you have both pieces of information. All right. 40 ohm coils. Any questions on that? 40 ohm coil? All right. So like I said, all right, a couple things, just listen. All right. And then there's how you test it. Just put your meter on resistance and check your resistance through it. All right. Now you've diagnosed technically 3 out of the handful of things we have here. You've checked the gas valve. You've checked 2 of our different limit switch thermostat combos. All right. Next thing we're going to talk about is this little guy here. Now, this oftentimes gets called a pressure relief valve. It actually does more than that. It is a P&T valve. And what P&T stands for is it stands for pressure and temperature. And that's what it's based on. It's based off both. So if we exceed a certain amount of pressure, it will open up to relieve the pressure. Or if we exceed a temperature, it will open up to make sure that we don't boil the water, in essence. And the 2 different ratings that this is set at is 210 degrees Fahrenheit. So if it reaches 210 degrees Fahrenheit, this will open, allowing the pressure to be relieved so we don't boil the water that's inside of this, or 150 PSI. So if we max out and send 150 worth of PSI worth of pressure into this water system, it will open up, relieving the pressure. It doesn't want that. When it comes to that P&T valve, though, all right, the way it does temperature, it senses temperature. Have you guys ever had one of these out? It actually has a white rod on the back. That white rod is actually the temperature rod. That's how it reads the temperature. That little rod senses the temperature, all right, and then relieves the pressure when you get up above that, all right? So that's the P&T valve. Now, these P&T valves are a little funny, all right? So I kind of mentioned in the beginning of this that a lot of different technicians have a lot of different thoughts on these, like don't touch them or open them every once in a while, all right? I personally, I'm on the side of open them once in a while to get the spring moving, everything like that. That way you don't have a buildup of calcium or iron or anything like that, which eventually causes these to leak. That way you're kind of flowing it through. But again, I can see the point as if you are working that spring excessively, you can cause it to weaken. I'm not talking like every once in a week open this thing. I'm talking once or twice a season. Okay. So I can understand both sides of it. If you're the technician that says don't open it, fine. If you're the technician that says open it, I understand. But if you do have to replace it, here's my biggest tip for you. Make sure you replace it with an OEM one. Okay. A lot of us have some different aftermarket parts on the shelf and everything like that. Those aftermarket P&T valves, they will give you more problems than the one you just replaced it with. All right. It's just the way it works. I don't know why. I've had nothing but bad luck with aftermarket like P&T valves. I would just replace it with an OEM, whether it's Suburban or Atwood, Dometic, whatever you want to call it. All right. Any questions on the P&T valve? Okay. All right. One last thing on the gas side that we're going to talk about is the sparker assembly. So I kind of mentioned the sparker assembly earlier, and here's my sparker assembly right here. You guys can see it, I hope. And my sparker assembly is really in 2 pieces. Other manufacturers like your Dometic will be just 1 piece of the wires attached to it, but this one has a spade connection, if you all can see it, all right, that you can take off right there. All right. This is a grounded sparker slash sense probe. And the reason I know that it's grounded is because you have the spark coming out of the porcelain sided. All right. Spark comes here and it has to go to ground. And that right there is the grounding side. Okay. That spark will jump off of that probe over to the grounded probe. And it needs to have a good ground on it or else it won't spark appropriately. Now, what I will say about this is that over time, especially consumers that say camp maybe next to the ocean a lot, all right, got a lot of sea water and everything like that. What will happen is a lot of corrosion will happen here on the face of this, all right, and then on the face of that, which will cause a poor ground. And if you have a poor ground, this will not spark properly and it actually won't sense properly either. So if you ever come across one that say sparks and maybe lights, but then does not stop sparking, that may be an indication to you that you need to clean up this grounding surface here. Okay. Now, the other thing that can happen is you can have some corrosion on this actual on these actual posts right here, and this will cause the same thing. It will cause it to spark, possibly ignite, maybe not ignite, and then definitely not sense. So you just take a piece of emery cloth or Scotch-Brite or something like that, and just clean up these connection, or clean up these forks, and it will probably start working properly. Now, if you do have a break in this, and what I mean by break is this porcelain here. If this is broken in any capacity, it does require replacement. It will not work properly if it has broken porcelain. So make sure you physically inspect these and make sure that they are in good condition. Okay, but that's how you'll diagnose one of those. Any questions on that, and a couple of tips you got with it? Good. All right. That's the gas operation. Any questions? Any questions on how to diagnose the components? The order of operations we kind of went through, anything like that? Because we're going to move on to the electric operation. It's much easier when it comes to the electric operation, I would say. All right. Now over here, I'll ask a question. Does anybody remember what color started the electric operation for one of the 4 wires that were coming in? I'm not gonna show you right now, but does anybody recall what color the wire is to start the electric operation? Anybody?
Orange.
Yes, absolutely. Is orange. Perfect. Whoever got that, thank you. All right. So it's gonna be that orange wire right there. Bang. Orange wire. Okay. So 12 volts sent to the orange wire. All right. Goes all the way over here to this connection that's in here. All right. Sorry, I pointed the wrong direction. All right. That orange wire right there. This is a 12-volt activated relay. You'll see that the hot right here, incoming on one side. All right. Right there. All right. And then the hot going out. All right. Now the hot going out goes up to your limit switch and thermostat. Okay. So when the hot comes out of that relay, goes up to the limit switch, goes through the limit switch, through the thermostat, and then out of the thermostat and down here. Okay. This little cover here, this oval cover, is going to be what houses your electric element. All right. And your electric element is right there. All right. Now you can see the black wire. The black wire is coming from the actual thermostat down here. Okay. And then your neutral comes from your neutral connection. All right. It just goes straight from here all the way to the element, because it's not the one that is becoming the open and close. Your neutral's already connected, always connected. All right. And all you do to diagnose an element, I'm going to give you 2 ways to diagnose an element. All right. First way, all right, is the most common way. All right. And I'll talk about it. I'm not able to do the full thing here because I don't have this full of water or anything like that. But what you're going to do first, all right, you're going to take your meter. Okay. You're going to turn everything on. You're going to put your meter on voltage. All right. AC voltage. Just like that. And you're going to take your 2 probes. You're going to put one on the neutral, the black on the neutral. Can you see it? Yeah. Black on the neutral. Red on the hot, which is your black. And you're looking for 120 volts. Now, obviously, you got to have it on. If you have 120 volts there, that's great. All right. You know you have power. That's a good way to start. If you don't have 120 volts there, you come back over to the relay. Okay. And make sure that you actually have power coming into the relay. All right. So you can actually pull that little wire out right there. All right. And you can check for power there. Now you got to go neutral to hot. All right, to make sure that it's completing the circuit, but you can pull that out and make sure you got hot there. Now, if you got hot in both those places, all right, obviously you got power to the element. Now, what's wrong? Well, could be a bad element. How do you diagnose an element? Well, let's talk about 2 ways. First thing you're going to do once you confirm that you have power, you're going to shut the power off. Whether it's unplug the actual wire like this one has, or shutting off the breaker, or unplugging the unit itself, I always recommend just for protection, because you're not sure sometimes if they labeled the distribution panel correctly. Just unplug the unit. That way you know you're not going to have any issues. Once you've unplugged the unit, you have to drain the water out of the water heater. Now, tip for you on draining the water heater: make sure you relieve the pressure off the water heater, or you're going to take a bath. Okay? Don't take the pressure off the water heater. when you start taking the anode out of this, anode, okay, it's not here, but start taking the anode out of this, it's going to soak. It's got pressure behind it. You're going to take a bath. Nobody likes to take a bath at 10 a.m. after you just got to work. So make sure you take the pressure off of it. Once you take the water out, and the reason you need to take the water out is because water is conductive. So if there's a short in the element internal in the tank and water is conductive, it can give you a false positive. All right. Because what we're going to do is be checking continuity or ohms across this element. And if it can give you a bad reading if you have water in it still. So take the water out. All right. And then you're going to take your meter. You're going to change it to continuity. All right. Resistance should say OL. And then all you're going to do, take your 2 leads. All right. Now, a lot of you will say, Ron, don't forget to take one of the leads off. That's perfectly fine. But because there's a break in the hot connection there, I shouldn't have any other shorts, but you can take it off if you want. All right. Just over the years, I've found that you don't generally need to, but basically what you're looking for is you're looking for that ohm. All right. You're looking for that resistance to be there. If you reads OL, all right, that means there's no continuity in it and you have a bad element. Now, that is the most common way to diagnose a water heater element that most technicians do. But since you guys are here, I always like to teach a couple different ways to skin a cat. So let's talk about the other way to diagnose a water heater element. So we have a AC/DC amp clamp here. All right, this is the type of meter a technician should have. I'm going to put it on 40 amps AC. All right, 40 amps AC, and that's going to be plenty enough to do what we're doing. All right, and we're going to leave this on. So we've done everything else. We've done our due diligence, but instead of turning the power off and doing everything like that, we're going to take an amp draw off of this element. Okay, all I'm going to do is I'm going to clamp around the black wire. Okay, leaving it on. All right, I didn't have to empty the water heater. I didn't have to do any of the extra turning the power off, anything like that. I'm just going to leave it on. I'm going to clamp around the black wire and I'm going to determine the amp draw. Now, if it is a bad element, it will have a 0 amp draw. All right. Because if you have no continuity through the element, it cannot pull any amperage because you cannot finish the circuit. All right. So if it reads a fat 0, dead element, bad element, needs replacement. All right. And how many amps should it take though? Well, that brings us to our last kind of board here. All right. We kind of talked about all these component diags. All right. The gas valve, check and open on a coil. The coil should read 40 ohms. All right. That's a good coil. If it does not read that, it's lower or higher, it's a bad coil. All right. Or OL is a bad coil. Both your limit switch and thermostat combos are going to be continuity. All right. Your element, we just talked about doing a continuity on that. All right. How to do that. And now we're to the amp draw portion. Now, to do an amp draw portion, determine how many amps that element's supposed to run, you need to first determine how many watts the element is. So this is called Watt's law. Okay. Now this is a pyramid, and how this pyramid works is side by side. If you have two of these different readings, and you will multiply these side by side. Top over bottom is division though. So what we're going to do is first look for our wattage. Now I know this element's 1440 watts, and if you ever have a question on the wattage of an element, I'll see if I can have you see it, but it's going to be printed. I don't know if you're going to be able to see it. Maybe it'll focus. It's going to be printed on the side of the element. It's probably really tiny and it's hard for the camera to pick it up. Mine is printed right there and it says 1440 watts. I'm going to take that 1440 watts and I'm going to plug it into the top of that pyramid. And then I know it runs on 120 volts. I know that straight off the get-go because it's a 120 volt system. I am then going to take 1440 watts divided by 120 volts, and that will tell me how many amps this is supposed to be pulling. All right, so 1440 divided by 120 is 12. And I know that that element should be pulling right around 12 amps. Now, is it going to be perfectly 12 amps every time? No, 11 and a half, sometimes a little, maybe closer to 11. You'll see. All right, it's not the most perfect math. It's a general concept though. Okay, if you're pulling consistent somewhere between 11 and 12 amps, that's a good element. If you're pulling 0 amps, it's a bad element. Okay, and that's how to diagnose a element 2 different ways. With that being said, though, if you've checked all these other components, okay, And these were all good, you know, your limit switch thermostats, your elements, your sparker probe, your relay here on the side for 120, and all those are working and this thing ain't firing. That's the culprit. Control board. Like I said, though, these control boards don't go as bad as often as some other ones on the market, but they still do go bad. All right. But I always like to leave the control board for last because this kind of thing right here, by diagnosing these other components, this is how you really learn how these items work and how you become a diagnosing technician in this industry rather than just something like a parts changer. Okay. People will throw boards at these units constantly, and it's not always the things. A lot of times they do get lucky and it's bad board, but that's how you diagnose all these components. Is there any questions? Because that's what I got for everybody. Let me split myself around so you can see me. All right. Is there any questions? Anybody learn something? Something? All right. Well, I appreciate everybody's time. I hope that was a little bit different for everybody than what we usually see. I hope you got some more out of it with the visuals that we did. And I hope you guys come back for some more of these. Have a great day, everybody.
Thanks, Ron.
Thank you.